Last year, we talked to you guys about some research that we saw showing the increased use of embedded software in mechanical systems such as airplanes, automobiles, medical devices, and even consumer goods. And we also showed that there was a study that showed engineers can expect to see between 10 and 20 defects per 1,000 lines of code used in these systems, and that the amount of code being used is actually increasing at a growing rate. Bottom line, for quality or test engineers in these areas, the situation is that they've got a lot of defects coming in that they must identify and resolve before they get to the customer.
This is obviously a huge challenge. Let's talk about what people are doing to actually keep up and test these systems.
So the V diagram is commonly used to describe how the software for these systems is developed. Now, for this particular challenge, the important thing to understand about the V diagram is that the software is really being validated throughout the entire process. First in simulation testing, then in rapid prototype test runs, and finally through a series of tests after the software has been deployed to the hardware that it will operate on in the system.
Okay, so you're testing more and you're testing earlier in the process.
That's right, but in order to stay ahead of this growing complexity and achieve timeline and budget goals, engineers are going to need to do more than just test earlier. They need a more efficient, better way to coordinate their validation efforts throughout this entire development process. So here to talk with us about how this can be accomplished, please join me in welcoming Meg Self, Vice President of Complex and Embedded Systems for IBM's Rational Group.
Hey. Hey, Meg.
Hey, how are you?
Meg,
hey,
welcome,
how are you?
welcome.
All right, Meg, welcome to NI Week. Why don't you tell everyone a little bit about what your group at IBM does to address some of the challenges that Chris posed.
Sure, thanks for having us. We really appreciate being here. The group was established really to focus 100% on embedded system design, both from a software and a system perspective. We bring value to the market by bringing really systems engineering methodologies and best practices together, really focused on product development of our clients. And so to that end, we do it from the beginning of requirements through modeling and implementation and into quality. And really, as you get to quality, it's really about, in our case, focus on compliance. And in those industries that have regulations, it would be on certification. We bring complete tools or complete solutions to the market, which do include tools and processes and transformational services, and it's done with an industry focus. Right now, today, the collaboration between, as you described, the right and the left side of the V is not really there. It's very limited. And with that, because that's limited, traceability is limited. And that really is important, and it's an important limitation. So as we're seeing that shift, we're seeing breakage in the right and left sides of the V, and we're seeing a lot of manual processes being inserted, which really breaks the fundamental rules of systems engineering. The next thing we're seeing, if you layer on top of it all that complexity that we just talked about and that you've been talking about today, this morning, that really ratchets up the problem statement even more, and it creates a pending need or an event for our clients to be able to bring those things together and integrate tools and processes in ways they had not before. Having said that, we really sought a leader. So we sought a leader in the area of the right side of the V and in test. And we really were excited to be able to join forces with that leader, National Instruments, to really be able to link these two worlds together in a more clear way. Right? And I think that's really, the fundamental difference.
It's clearly a significant area for opportunity to improve some of the things our customers are asking for. Let's talk about how we're actually, give an example application of where we're doing that.
Absolutely. It's all about the practical. Chris is going to show you the automotive example of the prototype. And even though it's one particular industry, automotive, that's being demonstrated, this really is applicable to multiple industries, any kind of industry that has product development as the focus.
Absolutely. Yes, so in this demonstration, the engineering team is tasked with developing software for an adaptive speed control unit. Now, we captured the requirements for this software in all of its various configurations inside of IBM's Rational Doors product for requirements engineering. And right from our requirement, we can jump into the test case that is used to verify, to validate that requirement. So now we're in IBM's Rational Quality Manager product, and this really gives the first example of the new possibilities, new capabilities that are being provided by the integration of our products. We can see right here in this test case, which is linked to the requirement, that we can have actually checked in or registered the test components that are necessary to validate that requirement. So in this particular case, it's the test stand sequence and all the associated files used by that sequence to implement the test validating that requirement.
And I think this is a really important point because before this, really we saw that breakage, right? There was no link between the test components and their associated requirements. And with that breakage, it caused a lot of manual processes to be done. And really in the case of a quality plan, those manual processes would be in the form of a spreadsheet. Now we can see that we can provide that direct linkage for these test components to be managed more effectively and through automation.
That's right. Yeah, and so this linkage, this traceability can be very powerful. For example, we can jump to a user-defined dashboard inside of IBM's Rational Quality Manager and see a lot of information about our current project. For example, what is the execution status of all of our test cases in this particular test plan? Now, this particular dashboard was created for a member of the software engineering team. And we can see here they've had a defect assigned to them based on a test failure. Now, this is another example of a great efficiency that's provided by the linking of our tools. Right from within this defect record, the engineer can immediately and without question of accuracy access the results that produce that failure. So in this case, you can see here the test stand execution report, the analyzed results and engineering reports that were produced by Diadem, as well as the raw data and other files necessary to reproduce this test are all included right within this system here, managed and linked. So it looks like in this particular case that we have an issue in the software. It's allowing the vehicle to exceed the speed specified in the requirement for that configuration.
So let's fast forward a little bit for the sake of time. Assume the software engineer fixes this defect, then what happens?
Well, as you know, when you revise software to solve one defect, it's quite possible to create others in the process. So therefore, any requirement that's been validated previously with the old version of the software must be revalidated if it's possible it might have been affected by the software change.
Yeah, and really, as you know, that's really the most time-consuming task or step that the test community has to deal with. And really, by integrating our tools in the way that we're doing here, it really virtually eliminates that impact on that team, which is huge.
Yes, yeah, this is big. So to show that, we wanted to demonstrate how we can do an automated regression test. And to do that, we've got 9 PXI-based hardware-in-the-loop test systems here. And they're connected to our unit under test, or really the hardware that will run this software, the adaptive speed control unit there. Yes, thanks, Eric. And so each of these test systems is actually registered inside of IBM's Rational Quality Manager so that it can automatically schedule and initiate tests as system resources become available. Now, there's a test suite that Stephen has here, which includes all of the test cases which might have been affected by this software revision. And so when he runs this test suite, Rational Quality Manager goes out over the network and looks for all of the NI test systems that are available and capable of running that test. It then deploys the test stand sequence over the network to these test systems. They begin running by downloading the latest version of the embedded software to the unit under test. It then will deploy a series of NI Veristan hardware-in-the-loop test scripts to exercise the unit and acquire data. And finally, it will use Diadem to automatically analyze those results and produce those engineering reports, and then place all of this information back up into the Rational Quality Manager system for defect management and traceability.
Right, so I think this, yeah, I think it's pretty cool too. I do, thanks for that. We really like this beginning, and really this integration that we're showing creates that bi-directional traceability that we've needed really in multiple industries. So it really is a great first step. It's just one example of what our teams are starting to do and integrate themselves and the tools and the processes together, really to be able to create this kind of value. So our clients, all of you, our mutual clients, are able to really focus on, reducing the risk and also embracing the complexity instead of shying away from it.
Very good. Yeah, Meg, we're thrilled to be working with IBM. I know there'll be a lot of people here excited about this and how this can really improve the productivity of their engineering teams.
We completely agree, and I think the most exciting part is it's just the beginning. And I think that will really be proved out in the next several months to years, and we're excited about it. So thanks for having us.
Very good. Thank you, Meg. Thanks, Chris.
Thank you.
Stephen.
Appreciate it.
Yeah, cool.